All right, hello, welcome to the Off by One security stream. Again, I've started using the counter because I'm tired of telling people in the beginning of every stream that we have to hold off for a minute and wait for it to connect to Twitter, X, Discord, LinkedIn, YouTube, all the places. So even though I'm repeating myself again now. But welcome to the stream. I know it's a different time than we normally do. It's 6 p.m. my time on Thursday. And it is 9 a.m. for Eugene in Singapore. So obviously, with those crazy time zones, you can understand why we're mixing things around a little bit here. But if you happen to join in late, of course, this will live on YouTube afterward, and you'll be able to watch it as many times as you want. But just a quick introduction to the stream. It's called Zero Day Hunting Strategy with Eugene Spaceraccoon Lim. Again, out in Singapore. And I just went and just kind of looked up again the background on Eugene and saw the amazing CVE list and all the amazing talks that he's done and everything. And this has been a guest who has been requested many times on Discord. So I'm very, very happy that he is so kindly accepted to join us here and kind of show us a little bit about his methodology and such around zero-day bug hunting and looking for vulnerabilities and all of that. So I guess, Eugene, if you want to give a little background on yourself to help people know who you are, that'd be great.
Yeah, thanks, Stefan, and thanks so much for having me and accommodating my time zone. So I'm Eugene. I go by Spaceraccoon on my hacker handle, and I really came up through the bug bounty scene, but then I got more and more interested instead of from web hacking into more vulnerability research, and that involved hardware, firmware, software, and wrote a book about it. And right now, obviously my day job, I'm a cybersecurity professional, run of the mill, but in my night, I like to do hacking as a hobby, and that's what I kind of term it. So I'd like to research anything, really.
Yeah, great. And I just posting the link right now to Eugene's book, which is a fantastic book, of course, called From Day Zero to Zero Day, a hands-on guide to vulnerability research. And it's one of the actually most commonly asked questions on the Off by One Discord. And just in general, when I'm talking to people is, like, how do I actually find the bugs? I've been told so many times that so many courses or different just resources out there always starts at, well, here's the bug we found and how we go about weaponizing it, but not the actual bug discovery approach. And of course, like, how do you know when something looks like it's worth your time investigating as potentially vulnerable post-mortem? And then obviously we have the exploit mitigations, which we talk a lot about here on this channel. And so, yeah, definitely grab that book off No Starch. And I see your No Starch shirt. It's a great, great company. Cool. All right. So I know we have, as always, I encourage questions. If you have any questions for Eugene or myself as well, of course, just go ahead and post them. If it's something, well, especially when he's demonstrating something that's related to what he's specifically talking about right then, I'll interject and say, hey, let's just maybe talk about this one real quick. Otherwise, if it's a more general question, we'll just hold it off to the end of the stream because we always do a little bit of a Q&A at the end here. But I guess tell us a little bit about what you want to show us today.
Yeah, so I think today I'm going to talk through the boundary research process of a particular hardware. So in this case, it's the Nokia Beacon 1 router. I'm going to hold it up here, kind of slot it in, and it looks like a standard router. And the annoying thing was that I thought I found something new for the stream about a week ago. And then I plugged it into the internet. Overnight it patched, and then now it's gone. So I thought, that's even better, because then we can talk about finding this particular vulnerability in more detail. I'm going to go through two things: a UART restricted shell and how I try to analyze bypassing it, and the second is just very standard web management interface command injection vulnerability.
Yeah, great. Yeah, I always think duplicates are things that happen in the web bug bounty world and not very often in binary exploitation and stuff. But but no, that's awesome. Like, you're able to show us something that's super, super cutting edge and fresh. And I will post all the links for Eugene's obviously X account and stuff like that, and a list of CVEs and his blog and everything as we go along here. And I'll post it as well in the YouTube description once it goes live afterward. But again, definitely encourage you to ask questions. Just a couple general questions, kind of like methodology or just high level questions that some people have asked on Discord for this stream. Is this one comes up a lot? Like, hey, I'm somebody who I've gone to what's the site I'm thinking of? Basically, I've gone to these different sites that post vulnerabilities and exploit write-ups, like exploit database is the one I was trying to think of, like exploitdb.com, and I've gone through the steps of recreating those the vulnerability discovery process and weaponized it and dealt with the exploit mitigations. But the question really is around like, hey, if I'm good at all the things, but I've mostly been repeating what other people have been doing, how would I get started figuring out what a good target is or attack surface is, and how, like, what are your thoughts around approaching that?
Yeah, I think the key thing is really just firstly understanding the attack surface available for your target. And that requires some, I think, much more specific knowledge. Where, for example, if you are dealing with an Electron web app that runs on your desktop, there's certain things you want to look out for. If you're running a pure binary, but it has, for example, deep links, or I don't remember what the Windows term for it is, but you could click into it. Those are also things that you can look into. And basically, the more you know about what possible attack surface could arise, the better, right? I think a lot of people get stuck on, I think, one of the more obvious attack surfaces, or something not very, I think, not very advanced, or that will be kind of the low-hanging fruit that other people will get. So the more you broaden your sense of the attack surface, and that's one of the things I talk about a lot, is then the more you have to get to look at, right? And that just basically expands your scope of research.
Another big question that someone asked, and I get asked this a lot as well, and I'd love to hear your thoughts on, is do you think binary exploitation is still a lucrative or rewarding path to go down in this day and age if I'm just getting started? Or do you think the mitigations and other factors are just kind of, it's not a great place to go? Would you recommend somewhere else?
Yeah, I mean, that's really an excellent point. I think, I mean, obviously, you still get to see, the very basic like stack overflows, buffer overflows, but then once you hit the binary exploitation part, that's why I kind of tend to have two in this mind, where there's exploit discovery and then there's exploit development. And exploit development is a whole field in itself nowadays, right? Where if you discover a bypass for a specific Windows mitigation, that could even be a finding in itself. And that is also part of boundary research. So I think these days, you're still going to find obvious stuff here and there, but it might be worth, like I said, just having more breadth to start with, and then you can go deep depending on the target once you find a foothold, and then really understand that particular attack path. But binary exploitation, I would say, is just one of the many tools in your toolbox these days. I wouldn't discourage anyone from going deep into it. I think obviously there's a lot of demand for it, and it's probably where you're going to find the most. I think, if you're looking for a vulnerability in like iOS or one of those kinds of exploits, that is extremely valuable. But if your goal is to just get started in boundary research, there's plenty of approaches you can take as well, outside of just finding memory corruption vulnerabilities.
Yeah, it's funny. I think a lot of people see the bounties on these exploit acquisition companies on targets like Chrome and Windows and iOS, and some of those get up into the millions of dollars. And of course, that's very attractive, but there's a big reason that those prices are there, because it's very, very challenging. And a lot of groups out there, it's not just one person. Usually it's teams of people who are sometimes well-funded or are working together to accomplish that goal. And a lot of these companies, like, they reach out to me oftentimes. I have a lot of brokers that kind of reach out and say, hey, do you know anyone that has information disclosure bug against this, or a blast door bypass? Because some of these chains are like 5-6 exploits long, and they're missing 1 or 2 pieces of it. And it can be very, very challenging. Absolutely.
Yeah, I think, one of the challenges as a person just starting out as like a hobby or as an interest is that obviously this is a big industry nowadays, and there are going to be organizations and teams that have, I don't know, like $1 million rigs running fuzzing, 24/7 for very, very specific types of memory corruption vulnerabilities. And what I like to say is that when people are zigging, you got to zag. You got to think of creative ways to get around it, or creative ways of reusing existing issues. I just saw, I think today, someone posting about weaponizing a DLL injection in I think Messenger or Windows, And DLL injection is one of those things where you kind of, I think when triages get it in bug bounties, they kind of like roll their eyes. It's like, I mean, yeah, sure, you got to copy and paste it, but the thing is that you got to weaponize it well so that it can be remotely executed, and it becomes much more of a journey based on the exact target itself. So even just having something simple that might not be very interesting or complex, but how do you weaponize it? I think that's also part of this journey of boundary research.
Yeah, absolutely. I was just talking to someone earlier. I can't say much about it, but I've said it on the channel before where my original intent with kind of training some models was to help me with end day research. So obviously Patch Tuesday comes out. My target's mainly Microsoft, and you download it from WinBindex and you diff it, find the delta in the code, and then you try to determine, is this worth my time? Like, is this something I think, based on my experience, I could go down that path and find something and weaponize it potentially? And it's very time consuming. All of us have spent countless hours troubleshooting and debugging and reversing something that at the end of the day, it's not possible to weaponize it, or at least I couldn't do it, or somebody else couldn't do it. And so I've been working on training these models around understanding as many patch diffs as possible over the decades. And my original intent was to help it with the actual patch diffing process and expedite which targets are good targets and which ones are likely weaponizable, if that makes sense. And what it actually ended up doing better was finding 0 days. And I just never anticipated or expected that. And the reason for that, and again, some of you may have heard me say this before, but the reason for that is that it's trained on thousands now of vulnerabilities, and over 90% of at least Windows vulnerabilities are privately or responsibly disclosed. So it's not like there's technical details out there. And so obviously, if you can weaponize these things quickly, they have a value to them. And that was my goal. But what ended up happening was when you give it DLLs or drivers, whatever you're thinking of looking at, it's finding new vulnerabilities based on the code blocks that it's seen before in patched vulnerabilities. So the first time that happened, I remember my friend from Berkeley and I were like, or UC Berkeley, we're like, whoa, it just called out this code block in this browser DLL and said, I saw this in CVE 2019 something something, and it actually ended up being a 0 day, which is pretty fascinating. And now we're up to 5 0 days from it. And just looking at that, one of those, just the other day, but pretty crazy. I guess one more question, and then we'll jump into letting you go and show us some amazing things, because I think it's another one that's on a lot of people's questions or minds, is your use of artificial intelligence, machine learning, kind of in your workflow. MCP servers, do you find that they're good at helping you document undocumented structures and just annotating code, things where you don't have the symbols? Are you using any of that, and what are your thoughts?
Yeah, I think a lot of it is really helpful for reverse engineering, to be honest. And I use it a bunch in my reverse engineering part of the weeks is just to kind of build out both an agentic flow, but also just incorporate it more in my workflow. I've been kind of planning to do it, and I've been hearing a lot of good things about people who have had success. And I guess obviously you have been doing a lot of work in this.
Yeah, totally. I've not found anything to be fully agentic. It's always got to be a human in the loop. Like, you got to follow up on this stuff. Just a number of hallucinations, but obviously working with the models and helping them reduce the hallucinations. And these general purpose models out there, I always use this analogy. If you go to a hospital, there's not one doctor who knows cardiology, oncology, emergency medicine, and all the other ones out there, specializations. It's all broken up into individuals. And just like the context, when you're working with a model on a context window, it starts to get a little crazy if you stay in it too long. And similarly, these models tend to work a lot better if you have their scope narrowed down to specific areas, but then have good memory management between them so that they're communicating. And it's just like a lot of hard lessons learned. And I'm lucky to live in Berkeley, where UC Berkeley's right here. And there's a lot of really smart people, smarter than I am around mathematics, but all good stuff. All right, let's see here. All right, so I guess I will hand it over to you if you would like to share your screen and just start taking us through something you think we want to see. Of course, we want to see.
For sure. So I don't have all my, well, obviously I'm going to try to like hold things up and hopefully this works. So I'll just kind of start with kind of background on why I got interested in this. And really, I just got interested in consumer grade routers and communications. And obviously it's a very popular target. It's one of the most biggest categories in like phone to own, and it's always been kind of intimidating. So I've always kind of steered clear. Like let me pick the easier like categories. Like I did some smart weighing machine, Wi-Fi connected weighing machine stuff, which is obviously a softer target, and definitely like steered clear of that. And I think this is part of why I wrote the book, and also why I'm doing the stream is that we want to demystify foundry research, make it more approachable, and make it seem like not something that only really well-funded teams and organizations can do. So this is a consumer-grade router. It's the Nokia Beacon One, and you often see it bundled in a lot of telco plans that they'll give you for free. And one of the things that you have to kind of start with is that if you look at the admin interface, so if you connect to your gateway IP address, you're going to see a web management interface, which is often, if it's a really not hardened a piece of hardware, you probably will find a command injection really, really quickly, like a diagnostics like ping interface or something. You can probably have a command injection. But in this case, I think because this had been out for a while, it was, I think by a fairly decent company. I know Nokia sounds strange. I mean, some people might be like, why is Nokia making routers? But they actually make a lot of telecommunications hardware and pretty decently as well. So it was fairly hardened, right? And it's one of those things where it's like, oh, in that case, then you then have to go into much more involved hardware hacking, where you can't just go from a black box perspective, but you do have to take it apart and do some reverse engineering. And this was kind of the start of that journey. So one of the first things I did, and this was like a hot tip, which some people who are very familiar with hardware hacking might kind of laugh at, is like, just look at where the stickers are, because I have tried to tear apart hardware before and spent a lot of effort and tore it apart with a lot of brute force. And before I realized, like, hey, there's a screw that's hidden under a sticker somewhere. And in this case, the sticker was really just hidden at the bottom of this piece. So there's like a little plate over here. There's a sticker with your QR code and the default passwords. Just take that sticker off and you'll find 2 screws. And that's what I did. And that gives you this, right? And again, it doesn't really tell you very much, but you can see where this interface is. You can see, for example, the WAN interface, the LAN interface, and some of the switches and pins over here. And what I did then, because I had actually a spare router, and that's in the back room, I took that further apart, was that I then had to take off these plates. These are like the RF shields that are meant to preserve the signals, but very annoying if you're trying to tear it apart. That took some effort as well. All right, that's the heatsink, and that's the RF shields here as well. And I'm going to try to like twist it a little bit and show you, see if you can see it. Let's see if I can get it out here. But essentially, one of the first things you kind of look at is for like a debugging interface. And in this case, I'm not sure if you can see it here. Okay. Yeah, you can see these 3 pins over here. And for those who are pretty familiar with hardware hacking, you'll be like, hey, that's a suspicious set of pins. I might start looking for a UART interface. But obviously, coming from this perspective, there's not much of information. You can't really tell, what are the chips in there. And that's when I had to kind of take all of this off. And from this angle, once I taken this RF shield off, I could finally see the components and basically look them up for what they did. So I could then identify where the flash memory is, storage is, and basically all the other like IC components on this board. And so I think in this case, for these 3 pins, what I then did was pretty much kind of basic hardware debugging, where I was just, put a multimeter in, understand where the ground port is. And fortunately, it was very straightforward. It was just a standard UART port with a 115/200 baud rate, and I was able to get a restricted shell. And that's usually pretty exciting because, that's the starting point for any kind of good shell. And I'm going to kind of put it on the screen here where we look at what the shell kind of went through and how I tried to enumerate it. Let's see.
Yes, it is a perfect time to watch from Australia. I know most of the streams aren't Australia friendly, but sometimes we have these good time zones.
Yeah, we got the APAC folks in here. So, okay, let's see if this is coming out. So let me know if you can see it.
Yep.
Okay, great. So this starts with pretty much like the bootloader, and this is one of the parts where you can. So there is a countdown when you're doing a bootloader, and you can usually just exit out of it and have a bootloader level view of things. But this is usually less interesting than waiting for it to actually load the operating system and get in there. So let me see if I can get that.
Yeah, whenever you can zoom, please do, because.
Oh, my bad. Yeah.
No worries.
I know you reminded me of it.
Yell at me right now. We're gonna try to preempt and not let them yell at me.
Okay. Okay, great. And that then lends you into the shell, right? And I'll be like, okay, great. Now I can get into it. And when you first start with this, you kind of want to have an orientation of where you're at, and you see like, hey, firstly, it's zebra BTY. That's something that you probably want to search up, understand what kind of shell you're in. And the second thing then is, you just want to run like help or some way of understanding what commands are available to you. In this case, I looked at it. It was like, okay, seems like it is a little bit restricted. There is a shell command to really get into the shell, but you got to input a dynamic password. So let's see if we can get there. And see what happens when I do that. Okay, maybe it's in the new one here. Okay. There we go. So I would then run shell, and it will ask for password 2, and it says password invalid, and that's pretty annoying. And at this point, I want to emphasize that like there's not a lot of complexity here. At this point, you just probably want to Google it. And here's when you kind of see some pretty interesting things. So let me just share this tab that is relevant. Let me share. Cool. And you'll see that other people have looked at the Nokia router before, right? And they have gotten pretty far. This is a pretty good blog post that talks about how you can get your shell if you basically rewrite the configuration backup file. But basically, I had a comment. People have also looked into this before. Some of them have found default passwords, and this was the problem I was facing, right? Which is asking for password 2, which is, I guess, a hardened version of the password for the restricted shell that has been introduced over time because people have found and cracked their default password. And no one has really gotten far with it. Everyone's kind of like begging, like, hey, let me know what password 2 is. And no one has really answered it. And this was what caught my attention because, hey, this is something new and interesting. And at this point, it's important to note that a lot of people are interested in cracking this, not because they are boundary researchers. A lot of people are interested in cracking routers and ONT, which is optical network terminals, because there are, for some regions, the telcos essentially store a hard-coded password and username in there that allows you to basically identify yourself to the telco and what kind of plan or a telco plan you have. So a lot of people are interested in cracking that because then they can change what internet plan they're on legally, I must add. So don't do this at home. There's a lot of interesting blog posts and research on this sort of work for this reason. So at this point, I was kind of stuck, and what I tried to do then was enumerate the rest of this restricted shell from what I had, and there were various interesting functions and that I could execute that allowed for minor like command argument injection, but it didn't really get me too far. So let me see if I can pull this up and show you some of my attempts at this.
Yeah, it's funny why you're doing that. I remember this. There was this NAC solution called Amigo Pod. I can't remember who bought Amigo Pod, but it was a NAC solution. And instead of enabling HTTPS encryption like you would expect to see on a NAC, they actually put a fake variable in that said password equals 0. And then they knew that most of the password like scanning tools like Kane and Able or whatever that people are using or were using, it would grab the first instance of password, the string match, and it would just show you, and it just showed 0 all the time. For password was 0, but below that there was another variable that was named like a underscore password, and it equaled, of course, an HTTP post, which is what you actually want. It's just one of those funny things. You made me think of it there.
Yeah, I mean, you'd be surprised what people use, what manufacturers put as a password, and kind of scary sometimes. Yeah, so at this point, and obviously this is targeted at a researcher who obviously might not have a lot of time. This is not your full-time thing. And while I could have gone really, really deep into the restricted shell, I was trying to look for some of the low-hanging fruits, right? And one of the most easiest low-hanging fruits is, simple command injection in any of these restricted shell commands. And what I basically did was that I gradually enumerated their defenses. In this case, what special characters were blocked in this restricted shell. So you could see here, I tried like $1 and then it would return invalid command. And I slowly went through all of them and realized they had a pretty decent block list. The only thing that was allowed was a arrow bracket, left side. I'm just trying to show you what that looks like. And that allowed me to then use some sort of redirection, right, in this restricted shell. But it just provided this as an input. It didn't really do anything else. And thus, I couldn't really get too far with it. There are a few instances where I could have in this case, this is a command that helps you show what network interfaces you have. But you can see you can pass this /etc password as an input. But it really didn't get me that far. And I think at this point, I was getting pretty frustrated. I was like, this black box is very annoying. I have to do this over UART, and sometimes the connection gets wonky. There's not a lot I can do. So at this point is when you probably want to turn to reverse engineering. And for hardware, I think a lot of people, when I first started out, was that I would try to download the firmware online through update packages. And manufacturers are getting smarter with that nowadays. They do like encryption. They don't reveal this. Nokia, in particular, doesn't actually expose these firmware update packages, and it also has some level of encryption for these firmware update packages. So I couldn't just rip it off the web and then start reverse engineering. And so in this case, I had to then desolder it. So I took this apart. I don't have the gory corpse of the other one I have, but what I did was then identify what was the IC component that was the NAND flash storage on this router, and then I desoldered it, and then I put it in a programmer. So this is what the programmer looks like. And what a programmer does is that essentially it helps you both read and write to chip off storage chips. In this case, what I found out about this, and it's quite annoying, is that there's very bad documentation for some of these programmers. This is a T48. I think, I can't remember which company it says, Heiko Singong Electronics Company. And we're very odd software. And what I did was that I took the chip and I put it inside here, so it could be read by the software. And this is what I'm going to share with you what that looks like. Okay, I don't think it's going to be great. I can't really expand the font size, but don't worry, we'll get out this really quickly. And essentially, you can just read it, right? Let's see if I can start a read at this point. Yeah. And it's going to be able to read the basically the raw bytes of this chip. So let's give it a couple seconds. Okay, it's going to verify it. And I think I don't want to like de-emphasize how annoying this can be. Essentially, hardware is really like squishy, and there are a lot of issues. For example, if you, I don't know, you shorted the circuit, then you basically lost all of the storage. Um, so this is also a skill in itself. And okay, let's see if I have read. Yeah, so now you can see basically there are a few kind of interesting things turning up in my read. You might notice a pattern at this point, and we'll talk more about it. But essentially, this was able to then dump it as a binary blob. And once I had this binary blob, what I did was then obviously try to run binwalk on it. And at this point, this is when things got a bit strange. So I'm going to pull that up, and hopefully I can share it. Okay, let's see how far we can get. So for those of you who had the pleasure of trying to use binwalk on things before, you know that there's a bunch of like issues that you might encounter. Most of them would be, for example, not having great support for various pre-binaries that it's trying to call. So in this case, I ran binwalk on it, and if you run it straight like that, you're going to get a bunch of errors, right? Okay, in this case, no extract files, that's fine. Yeah, so you got to pre-install UB Reader, and that's what I did. And what I tried to do was then manually run the UB Reader on the extracted files. And let's see what happens when I do that. Nope, that was in the other one. Okay, let me share my other one.
I always remind people that the demo gods are always, watching. But we always defeat them. We always defeat them.
All right. Hopefully you can see this at this point.
Yep.
Okay, great. Right. And I'll get this lovely error that says, less than 2 layer blocks found. And at this point, you kind of have to get into the guts of UB Reader and basically understand where all these errors are. And part of it, and the mystery of it was, it was recognizing the UB magic files, magic bytes, but then it would just error out because it was basically there was some kind of corruption going on, and so it wouldn't be able to extract anything at all. It wouldn't get any further. It wouldn't be able to extract, I think, the UB volumes, and that was strange to me because on the first glance, the extraction went pretty well. You could see the magic bytes throughout the blob, and it was just a mystery to me. And this kind of got me stuck for a while, and I then discovered someone who had faced a similar problem. And one of the things I would actually advise a lot of people dealing with hardware is that there's actually a lot of good resources written in Mandarin. So you might want to use Chinese search engines with your problem, and you'll actually get somewhere. And what I saw here was well, I'm going to try to flash it up here and see if anyone can kind of spot what's so interesting about this blob and what might be wrong over here. So this is the original blob that I extracted. Okay, I'm going to expand it a bit more. Okay, does anyone kind of see something strange going on here? And we'll go further down where there's like all this information. This is where the UB file, UB stuff is. Okay, so what's interesting here is that every few bytes, you're going to see this weird blob, and it keeps repeating itself throughout the extracted, binary blob. And this is what was messing up my extraction. essentially that for some reason, throughout my extracted bytes, there was this blob that was then corrupting, I guess the UB volume. And what I found out was that you really have to understand the hardware that you're working with. And in this case, this particular NAND storage chip was adding a checksum. Yeah, it's just sort of comments like, how do you not go insane? A lot of persistence. But in this case, there was adding a checksum every few bytes. And this is a fixed offset, essentially. And this is just how the memory layout is done for this flash chip. But if you don't actually know this bit of trivia about this particular chip, you're going to get really confused about why your bin walk is failing, right? And that's because of these extra bytes. And these bytes have no relevance to the actual stored information at all. It's just a checksum for the hardware to know that whether this particular block or page has been corrupted or not. And so what that means is then you just have to extract these, because these are regular offsets. So a simple Python script can do it for you. And that's what I did. I wrote a quick Python script to remove all these checksum bytes in the entire binary. And then binwalk was able to get a bit further. So I won't go all the way into the gory details, but obviously the binwalk didn't complete itself. I had to fix a few bugs here and there. Some pages were corrupted, and this confused the UB reader. And I just kind of got around it by basically directly editing the UB reader Python script and asking to avoid this page. I'm sure there will be better ways to do it. But that was when I was able to get a sensible amount of information. So I'm going to go back here.
And someone's asking, how did you dump the firmware blob again?
Okay, yeah. So I basically use a logic programmer. This is the screen I shared earlier. Basically, it's a piece of hardware that you can put various types of chips or various packages and formats in. And it basically will be able to read the correct pins. In this case, for example, I had identified that this was, so I'm not sure. Let me see if I can share that little pop-up. One sec. Okay, I'm going to try to share my entire screen so you can see it. Okay.
Whoa.
Okay. And what you see here is that you can basically, once you've identified what the device is, in this case, I identified that it was this particular model of the chip. It will be able to have a pre-configured pins to read from, and you'll understand basically how to read from it directly. So it was a bit of combination of hardware and software. You can buy these programmers online. I think for this was less than $100, but it's still very expensive. So there's a bit of a barrier to entry here. Yeah, but it's not as simple as put it in a USB and then you can read it. Unfortunately, there's a bit of squiggliness that I mentioned. So every time you perform an extraction using a programmer, the output's going to be different, slightly different. There's going to be a byte changed here and there, and you got to make sure it sits just right on the programmer. And there's all of these things to consider. So it is an inexact science, and you can really mess up your hardware that you're looking at if you do it incorrectly. So it's good to have backup targets. In this case, I had 2 copies of this. So yeah, let's move back into this. So let me pull that up. Let's see. Okay.
Hey, thanks, Shannon, for joining as a member. I think you might be rejoining, but if you're not, either way, thank you.
Okay.
Always remind people, all proceeds from the channel go back to the community, sponsoring people to DEF CON. We're doing a $500 giveaway coming up, and just everything from this channel goes back to the community, because that's what it's always started about and what it'll always be. So sorry, Eugene, continue.
All good, yeah. So now I finally extracted it, and let's see if I have, let's see if I have the right one. Okay, yeah, so very messy, but essentially I managed to get the fixed binary, and at this point I could then extract the various UB file systems without any issues. Binwalk would essentially work pretty well with all of them. And let me see if I can go into one of them, image 174. There we go. Cool. And that's what you want to see, right? You want to see the squash file system. Okay. Perhaps. Okay, maybe I had already extracted the image. 1, 2. Let go. Yes. Okay.
Someone's asking, they said, I thought Binwalk wasn't maintained anymore. Do you still find a lot of value in it?
So it's useful as like a first cut, but you're absolutely right in that Binwalk, I would say there are parts where it bugs out. So you can see in this case, I used Binwalk, but then it failed, and then I had to use the UB reader binary script directly, and then I also had to edit the UB reader script. And I think the thing to understand about Binwalk is that it really is just a wrapper around many other like extraction binaries. What Binwalk would do is that it would try to identify using, I guess, file or like other magic bytes, what little blocks exist in a blob or a binary. And once it has an intuition or it has had identified this using magic bytes, it will then run the relevant script or binary, in this case, UB reader, on that portion of that binary. And then you do it recursively. So most of the time, actually, if you are fairly certain about what you're looking at, you don't actually have to use Binwalk. It's not like a magic thing. It's just a convenience wrapper around many other things. Yeah. So that's the key thing to understand here. And so, what you see here is pretty much all of the things that you need to understand about the firmware. So as you saw earlier, there are actually multiple volumes. So some of them are like what I think is the backup firmware, and then you have the actual firmware that's running. So a lot of IoT tends to have this just in case like an over-the-air update fails, and then they need to like restore from a backup. And once you're in here, you're kind of home free, right? So if you look at the web's, if you look at the web's directory, I already extracted it, but you're going to see a bunch of CGI binaries. And I'll just quickly flash that up to show you how I got the initial command injection. And then the other part is that what I wanted to do was then search for the restricted shell. So if you remember the password 2 issue I faced and how it was asking for a password, but I didn't know how to get a password. Essentially at that point, that's really what directed my research, because I think one of the questions that came up is like, how do you know where to look? How do you know what to look for? So you got to be really focused. In this case, my focus was what is this password? Is it stored is it stored in the firmware? Is it stored on the device itself? Is it dynamically generated? And if you recall, when we looked at the text earlier, it said dynamic, right? So there's a bit of funkiness there that I would dive right into. But that was what I was looking for. So essentially, you can even run like a strings or grep search through the entire like file system just to look for like that error message. Where is this VTY restricted shell running? And then you'll be able to understand it. So right now, what I'm going to do is look and show you what the webs folder looks like. And you'll have to forgive me because there's a bunch of like IDA files already existing in there. But this is what the webs folder looks like, right? So you see a bunch of like .cgi, and the background is that when you're using the web management interface for the Nokia router, essentially that's where all the requests are being sent to, like these .cgi paths, and they map exactly to these binaries stored here. And for those who have not looked at like CGI files or like this kind of like web interfaces or IoT before, is that it's not good. Like a lot of these IoTs are very low powered. They're not going to be running like, I don't know, Golang with a well, some of them do actually, but they're not going to be running extensive frameworks that have built-in like dynamic scripts or anything. A lot of them are actually like pre-compiled into these binaries. CGI is, I think, Common Gateway Interface is a very standard like way of interacting that used to be in the old days of the web, but you see a lot in the IoT. And we're just going to pop up one of them, right? Let me see which one would be interesting. Log status. Yeah, I'm trying to figure out which one was the one with the issue. So yeah, I'm just going to open this first and let's see how that goes. So I'm going to share with you. So, okay. Let me share my IDA screen with you.
All right.
Cool. And so what typically happens is that you got to recognize patterns in how this particular device or firmware does this, and what you'll see in the functions list. So I'm gonna, okay, I know. Let me.
Yeah, if you can zoom, I'm saying like if you can zoom into that one at all.
Let me change it to like massive. Okay, and
Perfect.
this.
Perfect.
Okay, let me see if I can change this one as well on the left. Okay, thanks. Okay, great. So what you see is that basically for all these CGI binaries that you just saw in that folder, you know, you're going to see a common function that exists in all of them, which is CGI main. Typically, you might start from the entry function or the main function. There we go, main function. And that is actually a dead end. You probably want to look for the CGI main function. So again, this is not something that I think is standard playbook you can use for every single binary, right? Most times, if you start with a binary, you will look for the main function and then you go from there, the entry point. But in this case, you understand that firstly it's a CGI binary, so you should have a look at function list, and CGI main should stand out to you as probably where the main logic for responding to requests and responses from. So yeah, let's look at it. All right. So once you look at CGI main, you kind of know that you're on the right track because you see that, hey, this is what returns the response, the content type, the headers. Yeah, this is exactly what I'm interested in, right? You can quickly recognize a few utility functions. So in this case, CGI get post, you see it has a bunch of strings fed into it. You can intuitively understand that this is probably getting like the body parameter values, right? It's looking for these values. Can get this get query, which means that it's looking for a query parameter. So these are all like once you just have to like open it up, recognize these patterns, and intuitively understand what this function is doing. And so as we get through it, we'll see a bunch of interesting things. And the question is then, what are you looking for? So for me personally, if I had more time, I would be more than happy to go through every single CGI binary myself, fully map them out, understand what they're doing, and from there, look for potential issues. This is the source to sink approach, right? Where you have the entire attack surface, which is every single CGI binary, because that's reachable from the web, and then you slowly just enumerate all of them. Very time consuming, but very comprehensive. Now, if you're short on time, then you're going to use the sink to source approach, where you're going to look for very obvious, like dangerous functions, right? There are some binary exploitation opportunities here, but you could even just look for a command injection, right? So we look for system, right? So system is just a standard OS function where if you call it with dangerous commands, you can then execute a shell command. And we're going to look at some of this. And right away, if you see this system call, you would see that it takes in a string, and this string is ifconfig, %s, and it takes on this variable.
There's
and
no
then
path.
Sorry,
There's no path.
Yeah. So I mean, at this point, it's pretty obvious, right? We can just do a sink to source enumeration and be like, okay, how do I control this, string argument, and that's put into this format string, right? Because if you control this, you can pretty much easily just extract it. So let's go back. So we just look for v9. We're going to go up. I'm going to go through this a bit slowly. And you see like, okay, that's this function here. What could that be? Wow. They actually did a bit of homework, right? You understand that here, this looks like a sanitization / validation function, right? And I love reading these like logs, because this is when you really know that there's a human behind this who's getting kind of annoyed at people hacking their thing. And it is like, include shell command might lead to security issue. Grammar is not great, but you kind of understand it. I love this, because this is the part when you're like, okay, I'm on the right path here. And this is not a point where you give up, right? This is a point where you kind of understand what they're trying to block against and then try to find a bypass for it. So let's look into this stirker. So this just means that they're just looking for these characters that exist in your string that you pass to it. So let's look into this. Okay, so what are these characters, right? I don't know about you guys. You might live in hex and immediately understand what all of these are, but I'm just going to put it into CyberChef, and so that we can have a quick understanding of what these exactly, these bytes are. So stop sharing, share my tab. Okay, so let's see what it's saying here. And from hex. Okay, so yeah, you quickly have an understanding that they are looking for a decent set of bytes that tend to be associated with a command injection, right?
It's super tiny. It's super tiny, in case you can increase
Oh,
the
yeah,
font. It's like, I think 0.2.
Yes, I really appreciate that. Yeah. So yeah, it's looking for a few things, right? It's looking for like $, backslash. It's looking for like the tilde, not tilde, the backtick. All of these are common like command injection characters that you want to filter out. And then the question is, well, how will you bypass this? I don't know if anyone in the chat has any ideas, but there are a lot of ways to go it. You can even like just paste it in and ask your LLMs, but new line character, right? So you can bypass this with a new line character, and you could still proceed with your command injection, because the string as a whole was passed to /bin/sh. So as long as it's kind of something that you can enter in the shell and still works, it's going to do it for you. But we haven't completed this journey yet. We haven't confirmed that this is controlled by us, even though there are lots of good signs pointing that way. So let's go back in there. V9, right? So we're interested in V9. We're going to go up.
Yeah, pseudocode, yay.
Yay, yeah. And great. So you see, this is a directly controllable body parameter, right? When interface name. And yeah, I mean, the question now is like, how do I get here? How do I recreate this? And while it might seem like you have all you need, is actually now you have to actually create the exploit and run it. It gets pretty annoying, because what you can reverse engineer the parameter names. Sometimes might even be difficult, even with pseudocode, and even if you dump it into like, I don't know, like AI or something, and it tells you exactly what you need. It's not going to be fully accurate. What I like to do most of the time is that then I would go the dynamic route, where I visit the web interface, the web interface, and then use Burp Suite and then see what requests are going in, and that helps me typically get the proper shape of the request that I want. If I see this parameter, then I can inject it. So that was one way that I was then able to get this command injection going. Felt pretty pleased about myself. Why I'm putting on the stream is that obviously it's been patched, so it's not really an issue anymore, but this was an encouraging start. And there's going to be a lot more. And if I had time, actually, if I could just keep going, like basically the source to sync route, where I'm just going to go through every single CGI binary one by one, right, and find there are a ton of vulnerabilities, memory corruption, buffer overflow, all the standard stuff, and even some of these injection stuff. There's some of these that you can chain. For example, some endpoints will allow you to write to a configuration database and then there's some endpoints that read from that configuration database and then pass that value into like some kind of execution. There are many ways that you could then find vulnerabilities. But obviously at this point, I was still interested in my original question. It's like, what is this dang password that will give me the shell, right? So let me see if I can pull that up. 1 second. I'm gonna share this.
It's just a reminder for folks who joined late. We've got many hundreds of people here. This is something that Eugene discovered, found out that someone had already discovered it, because when he was about to, I think you can correct me, but disclose it, he already saw that a patch came out. So like this is literally something that just got patched, what, this week?
Yeah, so I'm not sure like which exact version, because the one I extracted might have been like a few weeks ago and so on. But still, it's fun, right? It's like,
Very
okay,
new, very new.
So yeah, I mean, it's not an official CVE. That's why actually that's a really side note point that I try to put in my book, was like, CVE does not equal a vulnerability, because there are lots of vulnerabilities that don't have a CVE. People just silently patch it, and you can always discover new things. And of course, for hardware, these are also especially relevant, because you might have an old version of the firmware and you just want to get a shell on it. So now you kind of know one way to get a shell on this on an older firmware, and there are downgrade attacks as well. And sometimes that's the whole goal. So let me try to pull up the right code that I have for you. I'm gonna give me 1 second.
Yeah, I want to do a session soon. It was a relatively recent Microsoft vulnerability that came out, and somebody who did a binary diff and was looking at the patch found out that Microsoft snuck in a patch that had no CVE assigned to it. Like, that happens every once in a while. That these silent patches come out, and it's very interesting.
Yep. Okay, so I think I have about what I need now. So let me just quickly open this thing. Okay, so at this point, let's get back to your original question, which is like, what is this password that this restricted UART shell wants me to get? And you will notice that this is not a solved problem on GitHub. People are begging for like anyone to answer them. And the fun part is that the reason why there is no fixed answer is that it is dynamically generated per device, I think. That's my suspicion. And what I did was then basically did a kind of like a sync to source approach, where I just look for strings related to my restricted shell, where it was prompting me for the password, and then figure out, trace back, right, what it checks against. So eventually my journey led me to this particular function called gen_var_len vty sh password. So for those who came a little late, early on, I was looking at the shell where I had connected using UART, and it was a restricted shell. It needed a password in order to unlock it and give you the full shell. And one of the first things I saw when I entered this restricted shell was that it says I am vty_sh, right? I guess it's zebra shell or something. You can kind of look, if you search those keywords, you can find various implementations online. But what you see here is, and I've already renamed the variables, was that this function takes in your serial number. So the password it's looking for is actually dynamically generated based on the serial number of your Nokia router. And that's why there is no fixed answer, because it's going to be different for every single router. And that's why people are begging for it online, because there's no great way to figure it out. But let me just quickly run through again how this is done. You'll start to see a lot of common byte swaps. This is very, when you're doing encryption and all kinds of funny things. That's what you're going to see. Let's see if there's a. Okay. Yeah, and you see it gives it a salt, and this salt is actually a fixed salt apparently in the function that called it. So again, this is pretty hard coded. And let's see whether I can right, and then we'll go here. We do various things. More byte swaps. Somewhat annoying. It will then read from this file. This encryption data, which is, I guess, used as the initial bytes for encryption. It'll do even more various things. Let's see what it do. And there is one part that I wanted to highlight. see this further down. Right. Okay. It does this function. So just think that at this point, it's just doing all these kinds of bunches of like encryptions. Right. And it basically does, yeah, it uses all these strings to then generate the final password. Right. And at this point, there is also an issue, right? Because they are using hard-coded secret keys. That's in the file, but that's also here. I'm trying to figure out where I can see it, but you can kind of get a sense that, okay, they have some level of encryption, but they didn't work too hard about it. They are using, standard like hard-coded like initial variables and keys. So there is still a way to get the final password. You just need to understand what the serial number is. And at this point, there are two ways around it. You can be a really hardworking like reverse engineer who is like, okay, I'm gonna just hunker down and completely reverse engineer these two functions so that I have a Python script or something that recreates it. And I just need to pass it a serial number and the encryption data file, and it's going to do it for me. Or you could do dynamic reverse engineering, where you in fact just emulate this binary, and it does it for you, and shortcut it, right? And before I continue, I just want to highlight this part where it's pretty interesting, where it's like if the output length is like X, and it's going to start just putting this random string that's hard-coded as well. So again, kind of sus and wrong, I think, because then there is a known set of strings. So I'm not sure if I'm supposed to be showing this, but we'll see. So let's get back into it. So the question is like, okay, I now understand how it works. There's some kind of encryption, and I want to like get a password, right? And there are two ways around it. I could statically reverse engineer this and recreate this as a Python script so that it's as accurate as possible, so I know what kind of password is generated. Or I can just short circuit it and actually run the binary with these arguments. And the question is then, how will you do that? And one of the things I covered in my book was like the use of firmware emulators, in this case, the Teeling framework. And let me try to pull that up for you. Okay, I'm going to make sure I increase the font size before I bring it in. So essentially, in the book, I talk about this framework. There are other frameworks you can use, but Teeling framework is, let's see. Okay, let me just. Okay, there we go. Teeling framework is a framework that allows you to emulate binaries in a firmware file system, right? So you've got to have the whole file system. Okay. You got to have the whole file system. In this case, I have the squash fs that I extracted previously. And then you just got to tell Teeling which binary in that file system you want to execute. And Teeling's pretty good about it. It just recognize, which processor architecture needs to run in, and it will try its best to run it as needed. It also stubs out a bunch of common API, OS calls, syscalls with reasonable alternatives, and it actually runs pretty well. So I'm going to go through the script that I wrote, and this was one part where I could use AI a little bit, right, to just help me like with the writing, but obviously I had to debug, and it wasn't accurate because not everyone. I don't think there's a lot of data on like Teeling scripts, other than documentation is not great either. One of the things with reverse engineering, but let's just jump right into it. So what I wanted to do is firstly set up which function I wanted to run. So in this case was the vtysh binary in the file system, and I'll also specify, in what root file system is this running in. The other thing was that because this binary would run in, it would fork, it would create multiple threads. This would cause various issues if you're using emulation. So Teeling has experimental support for multi-threading, so I had to put this in. It was kind of annoying. You could probably stub it out as well. And this is where I think where I could get to where I wanted to go, right? Which is that essentially I want to hook when it's running this generate function that we just looked at in IDA. And when it enters and exits, that's when I want to print it, right? I want to print out the output of that function. One of the things you see is that I printed out, I think, the param. So I wanted to print out the serial, not serial, the destination value, right? And that will be one way to then extract the password just by running it directly. So again, demo gods today, I'm not sure if this is going to work as intended. So yeah, let's see if I can get it. Okay, so it's running it. Right, serial length, and then you can see that it then prints out the password. Here, I had to print it out. You'll see the serial length. So I had actually mislabeled it, but this is actually the password that's generated. It's not the serial length. It comes out over here. So there's a bit of fuzziness, again, to all of these reverse engineering. You kind of have to like recognize it. But you would see here that I have basically emulated the firmware, run it, and then that allowed me to then basically get a password that would be created as part of this binary. So let me see if I can get to where it needs to be. Yeah, so I think we've gotten to exactly where we want to be. I've generated the password just by emulating this in TLIN. So that was the ending point of where I'm at. Now I kind of have an idea of like what password is expected, and that would then allow me to try escaping this restricted shell, because now I have the password that expects. But I wanted to kind of go back into the initial tab that I was sharing with you guys. So let's see. Right. So yeah. So there's this huge discussion where people are like, "How can I get the password?" You know, and people have tried, for example, command injection. Right. Various like hard-coded passwords, and all of these don't work because the difference is that now Nokia firmware dynamically generates the password based on a serial number. And if you theoretically reverse engineer this binary really well, you could have a script that other people can use as well. But unfortunately, I'm not as hardworking, so I essentially just wanted to do it for myself. Or you could even just put up the TLIN script and then feed it the serial number and ask people to run it and emulate it and get the password themselves. Yeah, so that is the journey. I've covered two things essentially. Firstly, how do you look for simple vulnerabilities using reverse engineering, get the firmware, look for system calls, other dangerous functions. You can do a sync to source approach. In this case, was also another like target where I was trying to get the password. Very interesting reverse engineering challenge. And once you hit the point where it's like encryption, you can be very hardworking, or you can just short circuit it with dynamic emulation and just get the password, them to tell you what the password is. Cool. Yeah, so I think that was part of the demo and my approach and process. Very, I think, hands-on and granular. I think I went into details in some parts, but feel free to ask, more general questions. I see a lot of comments as well.
Yeah, so one of the, I think the most important question someone asked is, where did Spaceraccoon come from?
Yeah, so I think when I first got it, I just saw like this piece of artwork that someone had made of this really weird looking funky raccoon floating in space, and they called it like Eugene the raccoon. And that was what I used for my my GitHub handle when I was just doing more software development and web development, and then it stuck, and I just started using it for my HackerOne handle. There was this really cool like image that I used for my profile picture for a while, and then basically I just contacted the original artist for that image, and I was like, hey, can you make something else for me that's more custom? And basically they did it, and that's what my current like Spaceraccoon mascot is. So yeah, trying to support the artist, the original artist.
Nice. I was telling Eugene before we started the stream that I'm going to Singapore next month to speak at the GovWare conference on AI for vulnerability research, and this is my 17th time to Singapore, and I think it's the food that always draws me back. But I was surprised to see chickens or roosters or something walking around on the road in this one area. Is that a pretty normal thing there?
My gosh, yeah. I'm not sure if you could hear it, but there was like chickens crowing not far from where I'm at. So all the geoguessers, I don't know if you can make an effort with this, but yeah, they're actually like jungle fowl, they call it. So it's not exactly like um, domesticated chickens. These guys are pretty much self-sufficient and live in the jungles. And yeah, no one eats them. I think there was a case where someone tried to like kidnap them and they got like, I think it's still a crime or something. But yeah, I'm really excited for you to be here. I think so.
I think last time I was in Singapore, again, I've been in Singapore a million times now, and last time I was there were some kind of critters hanging out in the alleyways by Clark Key and Robertson Key. I don't remember if they were like raccoons or beavers or something. Do you know what I'm talking about?
Otters, yeah.
Otters. It was otters, yes.
So again, it's one of those things that like they came. I mean, at first everyone thought they were super cute, and then they started breeding, and then they started eating people's like ornamental fish, and then they started creating gangs, and the gangs would like fight with each other. So
yeah. If you've never been to Singapore, definitely take a trip there. I mean, again, the food is amazing, the visuals are amazing, the architecture. I love Singapore. So a couple questions here. On average, how much time do you spend on bug hunting on a single product? I think there's a bigger question, which is we get asked a lot, which is like, how do you choose your target, and how do you know when to like stop?
Yeah, I think the first is that I have to have a pretty good sense of the attack surface. I need to know if there's somewhere that, if I see a web interface and it's an IoT device, then I was like, okay, if I could only just get the firmware and start reverse engineering it, then I would have a better sense of where it's going in. And that's typically where I pick a lot of my targets. When I pick the smart weighing machine, at first I was just looking for fully remote vectors, but then I read up online that another Redditor had found a UART shell in another version of it. So I was like, okay, this is great practice. I see the same pins on this device. Might be a good start for me to just get into hardware hacking. So I tend to look for an initial kind of foothold or something that's interesting that grabs my interest. It's really hard if you just kind of face a blank wall and you try to get feel your way in. I try to make sure I have something first before I dive too deep into it.
So I'll ask two questions in one. Somebody says, like, so is your main focus IoT devices? And I'll combine that with another question, which is, what would you recommend somebody focus on if they were like just going into this space? Like, where should they look?
Yeah. So this is a really great question because for the longest time, I've kind of avoided hardware. It was very intimidating. And honestly, for someone who had just done web and software, it was like, oh man, what are all these like nasty wires and things you have to like solder and it was once I started getting into the basics of it that it became, the learning curve just, made it a lot easier for me. And it's something I'm interested in, but not for the sake of just looking at IoT devices. It's just whatever's hackable. And if you look at some of the research that I focus on, a lot of it is crossover. Where for the smart weighing machine, I obviously started from a hardware foothold, which is the UART shell. But from there, I reverse engineered the binaries, understood how it communicated the API service, found a very standard authentication boundary between the API servers, and then was able to kind of like take over every single connected like smart weighing machine made by this company. So I think it's more about the crossover. I'm more interested in just hacking in general, and I'm not restricting myself to hardware for the sake of doing hardware. What was the other question again?
The combination question was on, oh shoot, now I'm going to forget.
How much time?
Yeah, I think it was more about like, how do you know when they call it quit? Like, how do you know you've spent enough time looking at an attack surface? I know a lot of this has to do with like your experience, obviously, and just all the lessons learned, because there's no way to get around the fact that you've got to do the time investment and pay your dues, and there's a lot of frustration. It's a humbling field because a lot of times you go down a rabbit hole or a direction and you end up realizing that you've wasted a lot of time. But don't look at it wasting time. Look at it as like, well, I learned a lot about that, and just really documenting stuff. But yeah, that was the question, was more about like, how do you know that you exhausted the attack surface?
Yeah, so I think the key thing is basically enumerating all possible endpoints. So I'll give the example of what I just demonstrated with this Nokia browser. And if I was interested in just the web interface, I would have made sure I exhausted, reverse engineering fully, source to sync all the CGI binaries in that folder. Obviously, when you first start out and maybe you're pressed for time, you might look for easy wins like I did, where I just look for all binaries, CGI files that called on the system syscall, the OS call, and then go back from there and then know it. But if I were to be like fully honest with myself, and now that I know it's patched as well, is that like actually if this was my job and I want to make sure I've done a proper job of it, I would make sure I reverse engineered fully every single of those CGI binaries in that web folder. And that's, I think, if you are in a proper like 0-day boundary research job, they will give you enough time to do that. This is just a hobby, so you got to look for the easy wins. But basically, like, have an idea of like where all the possible attack surfaces, and then make sure that you have actually looked into every single thing that's connected to that. So in this case, the shell, I would also look at, hey, if it exposes a telnet interface or any other like a port that's open, I'll make sure that I've also reverse engineered those binaries as well. And the key thing is that at this point, I know I've not done that as well, but I would know exactly like what I would have to fully cover. And there'll be limits to like what you can identify, what vulnerabilities you actually are able to exploit. But you can always come back to it later after you've done all these like hard work and groundwork for mapping out the attack surface.
Yeah, no, great answer. I always tell people too, like, if you are looking at a target or you're given a target, go and look at all the vulnerabilities that have affected it. Like a dumb example, like let's say somebody said, hey, I want you to take a product security assessment review of this SSH server and client. Look at all the history of SSH vulnerabilities. History repeats itself over and over again because, like, I'll give a quick simple example. Like the most basic example I can give, TFTP, Trivial File Transfer Protocol. It was used for the longest time to like send and receive voice over IP phone configurations, router and switch configurations, and other things. And there were like two main fields. It was the file name field and then the mode field that were the most vulnerable to things like buffer overflows. And also, like, a lot of times looking at history, because history repeats itself, and understanding the RFCs, if there's one associated with it, or any documentation around file formats like PDF formats, looking at all the historical data there and recreating those steps. It's good to have that knowledge as a foundation when you're going to approach something new, for sure. So one question, let's see here. Oh, where did it go? I just saw it. It was around, do you also use Anger or QIling, or like, what do you use? There's obviously a lot of other ones.
Yeah, I think Anger and Sealing are very like different tools. Anger is like symbolic execution, which is very interesting. It's a PhD level subject. The documentation kind of reflects it as well. So no, I just really switched based on what I need to do. Most of the time with firmware, you basically would use Sealing or a similar framework for emulation. There's a lot of good material out there already about like firmware emulation, but that's really key, especially if you're doing binary exploitation and you need a good way to basically make sure your offsets are right, and that's really, really critical. The really good thing about emulation as well is that you can control the control flow. You can control which part of the binary you're executing, and that's also really good for this level of debugging. In this case, I was adding hooks to then just dump out the generated password. Yeah, so really right tool for the right job.
I agree. Another question that came up on Discord was, if you had to tell your younger self a specific language to start learning, would you tell them C++ or Rust, or is there another one?
Um, that's a, I think that's a good question. I mean, I know Rust is super popular for safety and memory safety, and that was used in some parts of the Linux kernel as well,
And Windows,
um,
yeah.
and Windows, yeah. But yeah, that's a great question. I honestly would try to learn a little bit of everything. And the reason for that is that it depends on the target, right? So I've encountered targets where it's like, oh, what is this weird convention, and it's Golang binary, right? And then you have to kind of understand that Golang binaries look like this because they have all these like statically compiled linked compiled stuff. And then I'll look at a Rust binary, which has very annoying like function names. You've seen those before. And then I will look at and I'll look at some of those like C++ or frameworks where they have very strange like ways of doing object-oriented programming, and it looks different in the IDA or the Hydra window. So really, that really depends, but it's just enough to know what I know. And these days, there's really no excuse, right? Because you can ask an LLM or AI to kind of give you a better understanding of what you're looking at. So I'm thinking about this from a reverse engineering perspective. And there's one part where I'm like, not all binaries are even binaries anymore, right? They are actually just wrappers around packages that include, JavaScript, and then you have to have a different approach. So my take is like you got to be like a little raccoon, like digging around the trash and figuring out what you need. The adaptability is really important. There's no single one programming language that will get you where you need to go in boundary research.
Vibe coding raccoon. All right. Yeah, I mean, I know a lot of people that were like jumping on the Web3 space when blockchain and smart contract and the Solidity and all that stuff blew up, and then like metaverse kind of just fell off and didn't continue and rushing back. Let me see here. There was a couple other ones. I don't want to miss. I'm trying to go in order here. Obviously, we can't go too much longer. That's a good question from Graham. What do you recommend around like what do you use for taking notes when you're doing analysis? Do you use the Brain Wallet or using Obsidian or Notes.txt, or like what are you using?
I'm a terrible person that uses notes.txt. A lot of it is in the brain, unfortunately, and I want to be more disciplined about it. I think part of it is that like I'm having fun, so this is really just part of it. But I think the takeaway here is that I have a high level like understanding of what the attack surface I'm interested in, right? In this case, the CGIs. And then for each of the note-taking approach is very simple. For each of the CGIs, I just have a little like notes.txt or like a section of the markdown where I just kind of talk through everything. It used to be really early on in my research that, or at least in my bug bounty days, that I had a spreadsheet open where I have each column would be like a type of vulnerability I'll be looking for. And I'll just make sure that for like every endpoint that I had looked into possible ways of exploiting that type of vulnerability, just to make sure I had that comprehensive look through of all possible approaches. But yeah, these days I really just go from an attack surface oriented note-taking strategy.
Great. Let's go. I'm going to answer this question. So Actuator says, do you have a strategy for dealing with stack canaries on devices that don't appear to have usable RUP gadgets available and tools for binary exploitation or IoT? So stack canaries, like obviously for those that don't know, their job, they're very effective on preventing buffer overflows from being exploitable because they're protecting the frame pointer, they're protecting any local arguments, they're protecting the return pointer. It used to be some easy techniques on Windows where if you could trigger the structured exception handling to cause an exception before you get to the procedure epilogue, you could do something, but that's 32-bit only because they changed it on 64-bit. There used to be the case where different types of canaries were used instead of random. Random are the hardest ones. So obviously, if you got some kind of a memory leak where you can actually leak contents off the stack and you can have multiple vulnerabilities in the same application. There's cases where sometimes servers or services will fork or spawn or thread a child process, and it'll be the same one over and over again, where you can use brute force techniques, one byte at a time. But like canaries are a pain in the butt. They're not nearly as effective on the heap because unlike the stack where you've got the procedure epilogue where the function you cannot continue until you go through the epilogue, on the heap there's thousands and thousands of chunks, so the heap cookies and canaries can't be as effective. But a lot of people will obviously focus more on the heap exploitation, but that's one of the most effective mitigations. And now with things like shadow stacks and control flow enforcement technology, stack smashing is, man, it's almost dead finally, and it's been long enough that that's survived. But that's my response. If you want to add anything, Eugene, please do.
Yeah, for sure. I think you covered a bunch of it, and I would also say I think there's a couple questions related to this. I would also say that actually for the IoT space, it's actually pretty interesting because some of them, they're using older frameworks, or they're not running on very powerful hardware, and so they had to skip some of these mitigations as well. So obviously, if you're dealing with Windows, you have a lot of mitigations at this point. But if you're doing IoT, I mean, there might be cases where you even see binaries compile without stack canaries and stuff like that. So it is absolutely true that for some of the IoT vulnerabilities, you see much more straightforward exploitation. And if you if you check out the write-ups on some of these.
Yeah, it's funny because this is one of I always recommend people do CTFs because you're using the same part of your brain, you're solving complex problems, you're reversing, you're coming up with creative solutions. I 100% think they're valuable. But like in the Red Team Village this year at DEF CON just last month, the final challenge that only 2 teams were able to pass and get through involved T-cache poisoning on glibc like 239 or something, which is a very recent version, if not the latest. And they had to figure out a way to do a memory leak, and then they abused the stack. But like a lot of this stuff is so theoretical. I just, stack exploitation is really something I think is a thing of the past unless you find something like IoT devices or other obscure systems that don't really have those mitigations there as much as they used to. All right, let's see here. I would imagine there's less competition in this area, would you say, mainly because the initial setup needed and with full process you went through, what would you say is most difficult? So I guess the question's around like, is there a lot of competition in the areas where you do your research, and any tips you have there?
Yeah, honestly, I think IoT is one of those spaces that was like fresh ground, like even 4 to 5 years ago. It was just command injections everywhere. But I mean, the industry has really stepped up, and there's a lot of interest in the space, obviously, because IoT is everywhere nowadays, and governments and big companies buy all these expensive and very important IoT devices that are connected to their corporate and even other networks. So the security has actually really improved in the last few years. And I think the main thing is, like you said, there is a barrier to entry. You gotta buy the logic programmer. You gotta buy all of these hardware-related tools. If you really want to go really extreme, you can get very, very expensive really quickly with some of the equipment needed. But I think there's so much consumer-grade hardware these days that you can actually start with really just the basics. And if you're looking at those really important hardware, then yeah, you are probably a much more well-funded team or organization, because that's important to you.
Totally. Yeah. And Arbol, I saw your other comments around. Eugene can correct me, but the type of vulnerability that he just went through, there's no such thing. Like the stack canaries and stack exploitation execution, if that stuff wasn't involved. And then you said, I wonder if the heap functionality would be specific to the device you look at. So the heap stuff is interesting. Like I love heap exploitation, especially on the Linux side, because you can choose from the standard PT malloc 2. There's the old Doug Lee's malloc, DL malloc. There's TC malloc, which is thread caching malloc from Google. There's JE malloc, Jason Evans at Facebook. Like there's so many malloc implementations, and you can select the ones you're going to use potentially depending on the operating system. But heap exploitation is its whole own thing. But what Eugene just went through is more of a IoT kind of web interface vulnerability. Would you agree?
Yeah. I think obviously if you have seen snippets of the pseudocode, you look at some suspicious stir copies and stuff like that. Not really heap, more stack stuff still. But there are also mallocs and stuff going on. And I think that the key takeaway for IoT is really that they tend to be a bit more conservative with their implementations. Obviously, the architecture, the processor architecture is a bit different, but in terms of compiling, you won't see such interesting mitigations yet as you would see in like operating systems and Windows and so on.
Yeah, totally. It's a much more approachable area, I would say, because obviously in the world of the World Wide Web, I mean, there's so many more targets and there's so many more people developing things. You know, when you look at binaries, we all use Adobe or Microsoft Office Suite, so there's fewer targets. But on the web, it's just ridiculous in the cloud and like IAM exploitation and all that. Let's do one last question, and I'm going to let you go because I know you got work to do today on Friday in Singapore. Can weaponizing end days help you build more instinct for bug spotting or knowing which attack surfaces are most vulnerable? Have you done much around that space, or any thoughts?
So my thought is that not so much weaponizing it, because that's the exploit development. It maybe helps build some understanding of it. I think probably it was more speaking to patch diffing, understanding the end date, you see the CV record, and you try to recreate it just by reverse engineering the binaries. I think it's absolutely helpful and useful for bug spotting. And the key thing is that, and I did mention this as well in the book, is that sometimes some of these like hobbyists, like zero-day researchers, are kind of lazy. They're just happy with like finding one vulnerability, but you're going to have a lot of other variants just lurking around. And sometimes you just got to read the lines if they are blog posts or their conference talk as well, because they will probably have one slide that says like further research. These are the things I thought was super interesting, but I didn't have time to do it, and I will get to it eventually. Sometimes you don't get into it, and this is a really good hint for where your next research project could be. Just write on that, and there are additional things. And I know for myself that I have presented on boundary research where I just ran out of time. I know that there's stuff lurking if I spend more time in it, and that's where I put my stuff in that slide. And people have gone on and found other stuff with that.
Yeah, 100%. You and I were talking beforehand. I think I was giving an analogy, like if you find a gold coin, as you're walking through the woods, you're not going to just take it and walk away. You're going to assume there's more gold coins buried there. Like I owe Ivan Fratrick and many other people a lot of beers because they find a vulnerability. They publish the details, the trigger file, and then I just assume that there's other similar vulnerabilities in that space. And that's been proven over and over again, like Print Nightmare and all the Microsoft printing services vulnerabilities, all the RPC stuff, some of the most recent stuff, again, that started popping up again around, what is it, like when your Microsoft Office Suite, like when you were embedding an object, the OLE thing, the linking. Like, so many, and these are ancient in the Microsoft world, like back to the 90s vulnerabilities, and there's still bugs sitting there waiting to be discovered. So absolutely, patch diffing is a super huge resource and benefit if you get good at it. So all right, we're going to stop there. I will announce more information about upcoming streams coming soon, but big, huge shout out and thank you to Eugene. I would love to have you back on again. You have such a huge list of CVEs in your resume. And anytime you want to come back on and join us, I'm sure people would love to hear from you. Please check out Eugene's book. I'm going to put all that link stuff in the YouTube description. And I look forward to meeting up with you in Singapore next month. So we'll get some black pepper.
Yeah, and looking forward to meeting you too.
All right. Thanks, guys. We'll see you next time. Bye-bye.